Good day, good people. In today's class, tikuda kuita the magnitude or modulus of a vector. So let us kick off by defining terms. What do we mean kana tichiti magnitude of a vector? So the word magnitude is a synonym. Here's the synonym size. Saka this statement inongoreva kuti the word magnitude rakafanana nekuti size. So kana tichitsvaga the magnitude of a vector, basically tiri kutsvaga the size of that vector, but more formally tinogona kuti the size of the path connecting 2 points in space. So this path is connecting 2 points. So to illustrate this, let us say we have a line which is representing the vector AB. Saka this is our line. It's representing A, B. That is the displacement vector we have. Saka tine this displacement vector AB. Let us say with AB it's actually equal to XY. In column form, XY. That is what the displacement vector AB is equal to. Saka kana tichida kutsvaga the length of this vector, tiri kungotsvaga the length of this line, because for a vector you have to remember takadefine a vector as a quantity that has both what size and direction. Saka for direction, this arrowhead do not the direction, but you should also know kuti the straight line, the line represents magnitude, and remember the synonym of the word magnitude in the size. So kana tine two vectors, katiti tine vector rakadai so tozeta another vector rakadai, without even having to calculate the size of these two vectors, tinotoziva kutoti vector AB is larger than vector CD. So the length of the line or the length of the vector line do not the size or the magnitude of that vector. But if we are just given a line, and we are mathematicians here, we are just given a line, and we do not have a physical way of measuring the length of that line, what do we use? We go back to ancient Greece, we consult Pythagoras. So the Pythagorean the Pythagoras theorem ndo inoshandiswa kutsvaga the length of a line if we cannot physically measure it. How do we do that? We just get to that line, then tovataisa a horizontal counterpart like this, toisa a vertical counterpart. We make this a triangle, we make it a right angled triangle. Then takuchishandisa the Pythagoras theorem kutsvaga this hypotenuse. So the vector itself becomes an hypotenuse. Apa tinenge taisa a line representing the base and another line representing the perpendicular height. So whenever you have to find the length of a line, musina a physical way of measuring the length of that line, you are going to be using the Pythagoras theorem. Zvekutoti chiro mukadzokera ku topic coordinate geometry, muchaona kuti length of line is basically the Pythagoras theorem which is modified. saka patichazodefina kuti the magnitude of a vector inowanikwa sei. I want you to already know kuti the influence behind that formula is the equation, is the Pythagoras theorem. Okay, so after taita this definition, let us now define at length kuti tinowana sei the magnitude of a vector. So magnitude or modulus of a vector A, vector read A, is denoted as, remember the modulus tunoisa a bar toisa A toisa another bar. Anditika? So this is the denotation. This is how we denote the magnitude or modulus of a vector. Okay, tovatazoti where A is equal to, it's a three-dimensional vector, x, y, z. The size, the magnitude, the modulus of A is going to be equal to, using the Pythagoras theorem, it is the square root of what? X squared plus y squared plus z squared. Saka this is a very important piece of knowledge. So kuti even in your notes you have to box it up like that. You see? So the size of a vector, the modulus of a vector, the magnitude of a vector is equal to the square root of the vector components x, y, z. So kutoti leno tanga tine this situation, and if we have a 2D vector yedu tongoti ndi xy, the modulus of xy iningengori equal to the square root of x squared plus y squared, like that. And this is an application of the Pythagoras theorem. So kana tadaiso tinenge tatopedza magnitude of vectors. Chasara kuchita ma practice questions anotibatsira kuinternalize what we have learned. So we are going to go through 3 study questions or 3 practice questions, which are going to be from Nexus practice theory and also from Darshan K Gendah. We have this example. Yakati, for example, given that OA, so OA, position vector OA is equal to 3 minus 2, 6, and OB is equal to minus 1, 3, minus 2, like that. Sakandoma position vectors atapiwa, truda kutsvaga the size of OA, the magnitude modulus of OA, toda futi kutsvaga the size, magnitude, and modulus of OB. Then I'm going to give you a task after tatsvaga kudai. So the size or modulus of OA is basically going to be 3 squared plus minus 2 squared plus 6 squared. As simple as this. Then back to simplifier, this is the square root of 9 from 3 squared plus minus 2 squared into 4 plus 6 squared into 36. Saka panapa tiri kuti 9, 10, 11, 12, 13. Tikati 36 plus 13, 6, 7, 8, 9. Tukoona kuti apanza ndi 49. So this is equal to the square root of 49, which then is equal to 7. The reason why it is ngati plus or minus panapa, in a way kuti you cannot have a negative size. And we are not doing quantum physics panapa, but inenge negative masses and stuff. No, in the physical world, we cannot have a negative size. So modulus kana muchito idzidza, especially iri kuma functions, inenge ichishandiswa kunegeta. If we take the modulus of anything, zvinoreva kuti we are just going to have a positive value returned. Saka modulus inoshandiswa kuti tingova a positive value yatinowana after manipulation. So panapa you should make sure kuti your square root is not plus or minus, your square root is just 7 as that. Okay, saka after we have done this, OB is the square root of minus 1 squared plus 3 squared plus minus 2 squared. Take note kuti ndikuisa ma brackets here, they are important. This is the square root of minus 1 squared into 1 plus 3 squared, that's 9, plus minus 2 squared, that is 4. So 9 plus 1 is 10, then 10 plus 4 is 14. So panapa, this is the square root of 14. So we can leave our answer like this, or we can try to express that answer in sad form. But do we have such an occasion? I don't think we have such an occasion. So our answer is basically going to be the square root of 14. Now let us go to another practice questions. Before we do so, ngatidzokere kunoku, I want to give you a task. Saka task yenyu muzonyora answers yenyu in the comments section. Ndiye kuti ndoda kuti munditsvagirewo the size of AB ndo number 1. Number 2 ndoda kuti munditsvagirewo the size of BA, like this. So that is your task. What is going to be the size of AB? What is going to be the size of BA? Now on our second question, irikuti calculate the magnitude of the vector. Vector racho A is equal to I plus 2j plus 2k. Saka panapa magnitude of A, this is the denotation, is equal to, but before we even find the magnitude of A, tofunga tanyora A in column form. Saka A in column form meaning erichi 1, 2, 2. Remember, tinongotora chete machi ma coefficients are I, J and K. Kana kuta X, Y and Z. Saka tanyora A in column form, takuchitswagachi magnitude of A, which is just going to be 1 squared plus 2 squared plus 2 squared. This is equal to square root of 1 plus 4 plus 4, which is the square root of 9. Kurota our answer and the 3. So it's quite easy. It's quite straightforward and easy. Okay, let us do another question. Question yedu manje yakuti, if OA is equal to I plus 3j plus 2k, so as the end OB is equal to 4i minus j plus 5k. Question havayati, find the modulus of AB. Cannot find the size of AB. So kuti tuwane the size of AB, tinofunga kutanga taziva kuti AB wacho ndiani. So we know that AB is equal to the source point, the destination point, kunoperera vector OB, subtracting kunotangira vector OA. So this is equal to, then panapa ndakuchibatanidza because OB yangu ndinoda kuti even in column form. So I'm just going to be taking the coefficients here. Kureva kuti ndichatora 4 pana I apa. Then pana J, be careful kutora minus 1. Then panapa pana K, that's 5. Subtracting. What about OA? It's 1, 3, 2. This is equal to 4 minus 1 the 3, minus 1 minus 3 the minus 4, 5 minus 2 d 3. So this is AB. The modulus, the size of AB, the magnitude, is equal to square root of 3 squared plus minus 4 squared plus 3 squared. So here, what does it give us? From 3 squared we get 9, plus from minus 4 squared we get 16. Remember, the square of a negative is a positive. Then from 3 squared we also get 9. Saka panapa basically tiri kuti 18 from 9 plus 9 plus 16. 8, 9, 10, 11, 12, 13, 14. Then 1 up, 1, 2, 3. Saka it's 34. So panapa our answer is going to be the square root of 34. Of course, you can express it in sad form, but it's not so much a requirement. So kana tadaiswa madzangu tinenge tapedza. Kana ma lessons atiri kuitisa, including this one, if they are helping you in any way, may you please consider subscribing, liking, sharing, joining our community if you can. And if you want extra lessons, please WhatsApp us on this number, +263 71 521 3310. Thank you and take care.